Hi everyone, welcome to daily practice. In this video, I will explain you step-by-step solution for the question that you can see on your screen. So do watch this video till end, and if you face any doubt, you can share it in the comment box. So let's begin the solution. Differentiate with respect to x, sine inverse of inside the bracket 2 cos x plus 3 sin x divided by root 13. So we have to differentiate this given function of x. For that, we have to convert this given function of x into function of y. As this is inverse function, then we have to convert it into function of y. Then differentiate this function of y with respect to y, and then obtain dx by dy. And then by using theorem of derivatives of inverse function, find the value of dy by dx, which is equal to 1 upon dx by dy. Without any further delay, let's start solving this question. Solution. Now, first step is assume that the given function is equal to y. So y is equal to sine inverse of 2 cos x plus 3 sine x divided by under root of 13. Now as you can see that we have this sine inverse function, and we also know that sine inverse of sine theta is equal to theta. So in order to cancel this sine inverse, we need to reduce the term inside the bracket to function of sine. So how to do that? Let's see. Here we have sine inverse of. Now what I will do, I will separate the constant terms and function of x. So first I will write this constant term 2 upon root 13 into cos of x plus 3 upon root 13 into sine of x. I will do, we all know that sine a plus b is equal to sine a into cos b plus cos a into sine of b. Now we will use this formula over here to convert this function into function of sine. So how we will do that? Now here you can see that we have here cos of x. Here you can see that cos of b. Similarly, we have sine of x, and here you have sine of b. So what we will do? We will assume this term 2 upon 13 as sine alpha. So let sine alpha is equal to 2 upon root 13. So what I will get? This is triangle and this is angle alpha. So sine of alpha is 2 upon root 13. So this remaining side will be, I will use here Pythagoras theorem to obtain this side. So what I will get? Under root of 13 bracket square minus 2 square is equal to 13 minus 4 is equal to 9. So this side will be equal to under root of 9, that is equal to 3. So this side is automatically equal to 3. Therefore cos of alpha is equal to 3 upon root 13. So in this way I have replaced this 2 upon 13 with alpha, sine alpha, and then using this trigonometric ratios I have found out the value of cos alpha, which is equal to 3 upon root 13. So I will put these values in equation, and let sine alpha is equal to 2 upon 13 and cos alpha is equal to 3 upon root 13. Therefore this equation, I will denote this as equation 1. Therefore equation 1 can be written as y is equal to sine inverse sine alpha into cos x plus cos alpha into sine of x. Now I will use this formula in this step. And then I will get y is equal to sine inverse of sine alpha plus x. Sine alpha plus x. So in this way, I have reduced this bracket into sine alpha plus x, which is function of x. Now what will happen? This sine inverse and sine x will get cancelled. Then what will remain? Alpha plus x, which is this is called function of x. Now I will turn this function of x into function of y. I will shift this alpha to another side. Then what I will get? X is equal to y minus alpha. I will denote this as equation number 2. Then differentiate above equation 2 with respect to y. As I have converted this function of x into function of y, then I will differentiate this function of y with respect to y. So what I will get? Dx by dy is equal to derivative of y with respect to y will be equal to 1 minus derivative of alpha is 0. Therefore, dx by dy is equal to 1. Using theorem of derivatives of inverse function, what we will get? Dy by dx is equal to 1 upon dx by dy. The value of dx by dy is 1, that I will put here. So 1 upon 1. Therefore, dy by dx will be equal to 1. So this is the required answer for this question. So if you like the explanation, give this video a thumbs up and share it with your friends. And don't forget to subscribe the channel. If you face any doubt, share it in the comment box. So see you in the next video. Till then, keep practicing.